Hello students. Now we will perform the short circuit test on the medium transmission line. So if you see, I will explain you the connection. From auto transformer, this wire is connected to the ammeter. Now we have to change all the meters which we have used for the open circuit test. As the ammeter we have selected of 0 to 1 ampere range. So auto transformer to ammeter. Then wattmeter we have to select, which is unity power factor wattmeter. So from ammeter, if you see this green color wire, from this to wattmeter M, then MC short, and L is connected to the transmission line. Okay, and transmission line back to auto transformer, this red color wire. Okay, then V terminal of your wattmeter. Now V we have selected is at 75. Okay, 75 volt terminal. It is going to the base of transmission line, and in order to measure the voltage, we have connected a voltmeter across this auto transformer, so that we will get the sending end voltage. Okay, and on the receiving end side, we have to make the short circuit, so directly we will short the receiving gate. Okay, now this model is designed to carry the rated current of 1 ampere, so we'll apply the reduced voltage and we will pass the 1 ampere rated current. So we'll switch on the supply. So if you see the ammeter, lower scale, the lower range we have to select. So 1 ampere I have passed. Okay, and now see the voltage. 150 volt range we have selected out of 600, 300 and 150. So most lower range. So my voltmeter is showing me the 40 volt. So let us write it in the observation table. So otherwise we will measure it with the help of DMM once. Yes, 38.6 volts. Okay. So second reading we are taking. It is 38.6 volts. Current is 1 ampere, and if you see the power, the wattmeter is showing me 10 watts. Right? So power is 10 watts multiplied by multiplying factor. If you see the table, the strips are horizontal. So this wattmeter, if you see over here, it is 1/2 ampere. So lower current range 1 ampere, and voltage scale we have selected as 75, and hence voltage scale is 75. Okay, so 1 ampere and 75. If you refer the table, 1 ampere and 75. So my multiplying factor is 1. Okay, so my multiplying factor is 1. Now I will switch off the supply, and now again base is same, so I will interchange the upper two terminals of transmission line so as to take the fourth reading, so that all meters gets connected on the receiving end side, and we have shorted now the sending gate. Okay, so again I will switch on the supply. So again, if you see 1 ampere I have passed, lower current range. So again the voltage we will check on the receiving end. I will measure the voltage over here. So again see 38.9 volts. Okay, so my voltage is 38.9, and power is again 10 watts. Okay, so my receiving end power is 10 watts, multiplying factor is 1. Okay, this voltage is 0 as receiving end and sending end corresponding are short circuited. Okay, so we will switch off the supply, we will reduce the voltage and switch off the supply. Okay. So now from these observation table, you have to do the calculations by calculating the corresponding impedances at sending end and at receiving end side under open circuit and short circuit condition. And from those impedances, you have to calculate the values of ABCD constants, which is the practical method. And for theoretical method, the formulas are given in the write-up. You follow those formulas of ABCD constants of medium transmission line. And by using the corresponding line parameters R, L, C and length of the line, you have to calculate corresponding values of ABCD constants. And then you have to compare the ABCD constants calculated practically and ABCD constants calculated theoretically, which are same or not. Okay, so that is the experiment of ABCD constants of medium transmission. Thank you.